Hi everyone. So today we'll be talking about functions. We'll go through what functions are and what you really need to know in order to solve any problems with functions in the SAT. So what really are functions? This is the notion of a function, and it's the same as writing y equals mx plus b. Just an example here, right? Functions can be linear, they can be quadratic, but just as an example, if we write y equals mx plus b, we can also write it as f of x equals mx plus b. So the function is essentially an output. In this case, x is your input and f of x is your output. So let's say we have a function that's called f of x equals x plus 2. So what do functions do? Let's say I replace the x with 1, then this f of x is equal to 1 plus 2 or 3. So all I did is when I have the x replaced with f of x, or the x that's in f of x gets replaced everywhere throughout the function. So if I substitute x for 1, every x on the right side of the equation gets replaced by 1. If I had something like f of x equals x squared minus x minus 1, and if I wanted to find, let's say, f of 2, then that would become 2 squared minus 2 minus 1, or 4 minus 2 minus 1, which is just 2 minus 1, or 1. So that's the very basics of function. What you need to know for the SAT is when you have this function denotion given in a question, and they, let's say, ask you for something substituting in x, you have to make sure that you change the value of x everywhere in your output. And when I say that, let's say in this particular question, if I give you f of an orange, then your answer really would be orange squared minus orange minus 1. So it's as simple as that. Whatever you see in the input, if you substitute the value of the input, you have to substitute it everywhere in your output, and that'll become your answer. Now let's take a few more complicated examples, right? So if we have a function f of x equals x over y. In this case, when I say f of 1, it becomes 1 over y. So only the variable in the input that's being changed will affect the output. So in this case, since x is being changed to 1, the x on the right side of the equation also changes to 1. The next thing that's important, again from an SAT perspective, is we know about composite functions. So let's talk a little bit about that, composite functions. Let's say I have two functions given to me, f of x equals x squared and g of x is equal to, let's make it a little simpler to start with. Let's say f of x is x plus 1 and g of x is x plus 2. When we talk about composite functions, the denotion is something like this, fog of x, or you can also see it as f of g of x. We're trying to find a composite of g in f. So f of g of x can be rewritten as f of g of x. And always in these kind of questions, we have to start from the inside. When I say we have to start from the inside, what I mean is in this question, if I'm trying to find f of g of x, the first thing I'll do is substitute the inside and call it as f of x plus 2. Why did I do that? Because g of x is x plus 2. The next step would be you take the x plus 2 and you substitute x with x plus 2 everywhere on the right side of your original equation. So this is a very important step. A lot of people make mistakes in this. You take the inside and you substitute it for x everywhere on the outside. So in this case, your answer would become x plus 2 plus 1, which is x plus 3. Why? Because x plus 2 replaces the x here and the plus 1 stays as it is. So that's what composite functions are. If I do it the other way around, let's say I wanted to find g of f of x. Then in this case, I would say this is g of x plus 1. And then I'll look at the function g of x was x plus 2. So now, since I'm finding g of x plus 1, I'll substitute all the x's in the equation with x plus 1. So it will become x plus 1 plus 2, which is x plus 3 again. Think of it this way. If I change the input to x plus 1, everywhere in the output that x has to change to x plus 1. Let's take a little bit more complicated example. I'm saying f of x is 1 over x, g of x is, let's just call it x minus 1 for now. So in this case, f of g of x would be f of x minus 1, which is the same as writing 1 over x minus 1. Now see how x minus 1 is completely under the denominator, because all we're doing is we are replacing the x with x minus 1. So that's why this denominator, the whole x minus 1 goes into the denominator. Same thing with g of f of x. That's the same as writing g of 1 over x, and in this case the answer would become 1 over x minus 1, and the minus 1 would be on the outside, not under the denominator, because we are only substituting the x part here and not the x minus 1 as a whole. So a very important concept of composite functions. We really need to know this for the SAT. The SAT will have several questions where, let's say, you're given an equation of a parabola, and they will give it to you in this form: f of x equals x squared. So you need to know that this is the same as writing y equals x squared. That pretty much concludes everything we need to know about functions at the moment. In our next lecture, we'll cover some more questions in functions, so we'll do some real SAT examples, and we'll take it to our next lesson from there. Thank you everyone for watching. If you liked the video, please like and subscribe, and please put in the comments if you would like me to create any other such videos. Thank you again.